I have to find out the reduced density matrix of this. And if you say that this is just rho 1, it means this has to be the reduced density matrix. So it need not be the case. The thing is, you go. So whenever you do mathematics, you go with the definition first. Then you see, you may find something. So if I just use the definition of physicist, then what is this? I have to take some basis corresponding to the second system, and whatever there is, let it be there. And then again K. Right? And again over K. This is the definition of physics. But they are hiding something. What they are hiding? They are hiding this fact. So the mathematical definition is this. And here it is I. So when I'm writing I1, it means this is the identity matrix. Dimension of this identity matrix is the dimension of the first system. That's why I'm writing I1. And then what I'll do is that, you can manipulate this. You can do this calculation in many ways. Okay. What you do is that, for the purpose of practicing it, you just write down and play with it. Okay. Try to write it in a different way. Okay. I'll write in my way, but you can try to write it in your own. So this then could be equal to K. What will be the next step? Okay. For that, you can use many tricks. But if you want to write this, then what possibly you can write? This you can possibly write as this one. Yes. And then U. So I'm just removing this bracket. I'm not doing anything. So let me just remove it from here. Okay. Oh, it is here, but this one. Now somehow I'm being here, so I cannot do this tensor product. I cannot make a product this with this one. So earlier I asked you a question for the physics student. Here you will see why did I ask you that? Because here you cannot directly make a product. Because this is not given in terms of a tensor product. You cannot make a multiplication. But you will see, if you write, and here you can see why physicists write this way. But if you see this, then this will actually be K. This will be 0. Actually, this is 0, 0, okay, because it's identity. So this means every entry of identity matrix is getting multiplied with K. So then this will be this, and this will be this. And then this is getting multiplied with Q. Then U also you can split it in this term. Okay, assuming that it is, I'm assuming that I1 is a 2 by 2 matrix. So that's why I'm writing it this way. It will be like this. And then if you multiply this, then you will see a miracle. And that's what physics people write there. You'll see that this means this K2U11. Here it will be K2U12. Here it will be KU22. And here it will be K2U22. And whenever you have right hand side, also similar kind of a thing like this here. Okay, forget this. Suppose that this is entirely a matrix, and that I'm doing it here. This is that matrix. Okay, the entire matrix which is U, and that's what I'm writing here. And then whenever you have a right hand side like this, then you have just this thing, which is getting like K, 0, 0, and K. And then again, if you multiply, then you automatically see that this will be K, this will be K, this will be K, and this will be K. So when physics people write this, that they don't write this, it means whenever you have a matrix here, I'm multiplying this from the left and right hand side. Inside that matrix, there are submatrices of the same dimension where these are individually getting multiplied inside the matrix. And that's why they write it. That's the entire story. Okay, I'm not focusing this, so you can try to calculate and see like what is the meaning of this. Okay. Why do they write it this way? But let me just forget about it. Okay, so I want something, so I directly cannot multiply here. So I want to play with something like this here. Now this is my row times 0, 0. Okay. And this is some U dagger, and this is here I1 tensor K. 2. K. And this 2. So then what I want to do is, since here I have nothing like that, which I can multiply with, and I can have a nice term, nice formula to multiply the entire thing, I'll split this up, and I'll split it up in this way. So I'll forget about this and I'll write it in this way. I1 tensor 0, and then row, and then I1 tensor this. Okay, here I need to write I row tensor I2, and then here I'll write row tensor, this is I1, and the 0 here. And see, the entire thing is nothing but this one. This entire story is nothing but this one, because you can now component wise multiply, because everything is now tensor product form. So this 0 will get multiplied here, this row will multiply with identity, but it will remain the same. So this identity will get multiplied with this one, it will remain the same, and this 0 will get multiplied with this one here. So ultimately we will have this one. Okay. Now once we do that, then I am to see what is this, and I am to see what is that. Let me write this matrix as some EK, and this is just the conjugate transpose of this one. So let me write this just as EK dash. Then what I can see here, is that this entire thing is now this. Okay. And I want to find out what are these EKs and EK plus. Okay. And it is interesting to see that this EK matrices has a nice property. Okay. This EK matrices will be what? If you calculate this, EK dagger, EK, then what do you get? Just do a little bit of calculation and see. It is nothing. It is just you have to multiply. You have to take first this one, you have to take this one, and then component wise you just multiply. And tell me what is this? So what is this matrix? This matrix is actually my rho 1 dash. That means this is my reduced density matrix. Okay, or this is, I'm not writing is rho 1 dash because rho 1 I had written here. This was rho 1. So this is the evolution, because this is now the reduced density matrix of the evolved state, evolved density matrix. This entire matrix here, whatever I got, this is, so what we had earlier is this, rho 1, 2. This is my joint system. This goes to rho 1, 2 dash, which is this one, which is U rho 1, 2. Rho 1 is of this form. Okay, U dagger. Then there is a reduced density matrix, trace 2 of rho 1, 2. And it equals to trace 2 of rho 1, 2 dash. And I have found out this one. this equals to this one.